Volcanoes are another important result of the dynamic movement of Earth's interior. Everyone has an image of a volcano in their mind, but there's actually a great deal of variation between one volcano and the next. Fundamentally, a volcano is simply a location in the crust where magma from the mantle can find its way to the surface. They form above magma pockets or pools of magma within the crust, which frequently form near subduction zones around converging tectonic boundaries, and provide an escape route for the building pressure within the magma pocket. When molten magma from within or beneath the volcano finds its way to and breaks through the surface, the volcano has erupted. Volcanoes do not have to be mountains, and their eruptions are rarely blatantly violent, but regardless, they have a significant impact on the surrounding landscape. Most eruptions are considered non-explosive, which means that lava sprays, runs, or leaks from cracks in the crust. There's no explosion of energy, rock, and ash, just a steady flow of lava. In some locations, these non-explosive eruptions can be continuous for weeks, months, or years consecutively. As lava leaks out, though, it solidifies, becoming new volcanic rock. The continuous deposits of volcanic rock around volcanoes erupting non-explosively can drastically reshape a landscape, destroying older lands and building new ones. Many islands, such as the Hawaiian Islands or Galapagos Islands, have grown out of the sea because of the accumulated deposit of non-explosive volcanoes. Explosive eruptions are much rarer, but they are the ones immediately recognized as matching most popular conceptions of volcanic eruptions. An explosive eruption can destroy hundreds of square kilometers in minutes, blast millions of tons of lava and rock debris, ash, and gas into the air, and cause massive landslides and mudslides. Most volcanoes are best described as either explosive or non-explosive, but many will go through phases as both during the lifetime as an active volcano. Each volcano, whether it's a massive mountain or a small fissure in the ground, has two main parts. The first is the magma chamber, which is a pool of magma fed from within the mantle building either within or below the volcano, and the second is a vent or multiple vents in the case of most volcanoes. These are cracks or openings in the surface that allow gas and magma to escape the volcano. Once magma reaches the surface, it is now called lava. The chemical composition of magma or lava, what substances it is a mixture of, can have a large influence on how it erupts. Thicker, more highly viscous magma tends to trap more gas than thinner, low-viscosity magma. Similarly, magma with a large amount of dissolved water tends to have more trapped gas. This leads to a more sudden buildup of pressure and increases the likelihood of an explosive eruption. Once a volcano does erupt, what comes out is divided into one of two categories, either lava or pyroclastic material. Lava is the molten rock flowing out onto the surface of the earth, while pyroclastic material is any solid material blasted into the air by erupting volcanoes. Both forms of volcanic material are usually present during both explosive and non-explosive eruptions, but lava flows are much more dramatic with non-explosive eruptions, and pyroclastic material is most noticeably launched into the air during explosive eruptions. Lava is even categorized into different types based on its ability to flow, called viscosity. Pahoehoe and block lava are both types of highly viscous lava, meaning that they're thick and slow-flowing lava. A'a and pillow lava are both highly fluid, low-viscosity lavas, allowing these types of lava to flow more quickly. The most evident difference between these types of lava is how they solidify upon cooling. The next images demonstrate this diversity. Pyroclastic material can be either lava thrown into the air during the eruption that solidifies before reaching the ground, or solid pieces of rock from the volcano's surface thrown into the air by the force of the explosion. It can range in size from fine dust called ash to massive boulders. Pyroclastic material is further categorized, but the important differentiating characters are whether or not the material originated as magma within the volcano, or a solid rock from the surface, and the mass of each sample of material. When pyroclastic material starts running downhill, as anything with immense mass tends to do, it can cause intense mudslides and landslides. These intense movements of matter downhill, called pyroclastic flow, can be the most far-reaching and devastating results of an explosive eruption. The material flowing downhill can move very fast, possibly hundreds of miles per hour, and can have extremely high temperatures, giving it great destructive potential. When a pyroclastic flow is saturated by water from rivers, lakes, or melting ice and snow off the side of a volcanic mountain, it's called a lahar. The combination of water and volcanic debris makes a lahar more like a moving wall of cement than a common mudslide. Volcanic eruptions can have long-lasting effects beyond the immediate destruction. In addition to the explosion of lava and pyroclastic material, volcanoes also emit large volumes of gas, many of which are greenhouse gases. The greenhouse gases released from volcanoes during and between eruptions can increase the insulating effect of our atmosphere and cause Earth's temperature to increase slightly immediately after an eruption. The ash out into the air can actually have the opposite effect, blocking sunlight from reaching the Earth and causing the temperature to drop slightly for a short period following the eruption, lasting up to several years. Before man started burning fossil fuels, the release of greenhouse gases from volcanoes helped to maintain our atmosphere and temperature. We have since increased the amount of greenhouse gases in the atmosphere beyond those natural levels. An eruption can also destroy ecosystems. The heat, wave of energy, and moving lava and pyroclastic material radiating out from an erupting volcano can destroy nearly all of the plant and animal life in the area. After an eruption, ecosystems often have to start growing again from the bare rock up, in a process called succession. First algae, moss, and lichen have to reestablish the soil. Then small hardy plants can begin to fertilize the soil. Next, larger plants can begin to move in and further establish the soil. And then finally, the large competitive plants of forest climax communities can establish themselves. The images show the area around Mount St. Helens. The first, 5 years after the eruption. The second, 22 years after the eruption. It has taken a long time, but you can see the slow improvement of the ecosystem. As mentioned earlier, volcanoes aren't necessarily mountains, just points on the crust where material from the mantle can reach the surface. The mountains often associated with volcanoes are actually a result of repeated eruptions over time and accumulating solidified volcanic material. There are three main types of volcanic mountain. The first, shield volcanoes, are wide, shallow, sloped mountains growing from continuous non-explosive eruptions. The Hawaiian volcanic mountains are this type of mountain. The second, cinder cone volcanoes, are usually smaller with steep slopes and result from the piling of pyroclastic material after explosive eruptions. The final type, composite volcanoes, are caused by a combination of these two processes. These volcanoes have had a history of both explosive and non-explosive eruptions. So the mountains are comprised of both solidified lava from non-explosive eruptions and compiled pyroclastic material from explosive eruptions. The massive mountains in the Pacific Northwest are primarily composite volcanoes. They are also called stratovolcanoes. Volcanic mountains change over time, bulging before eruptions and growing or collapsing during eruptions. Often, eruptions leave a crater at the top of the volcano, which results from the piling of debris in a ring around the central vent. Since these are the results of eruptions, they change shape constantly. If the magma chamber beneath the volcano drains for any reason, the volcano can actually collapse into itself, leaving a large depression in the mountain, or earth, called a caldera. Yellowstone National Park is made up of 3 such calderas. If lava leaks out along a fault line instead of from a single point in a volcano, it can build a plateau, called a lava plateau, instead of a mountain. The Grand Canyon formed when the Colorado River weathered and eroded its way through such a lava plateau. As has already been mentioned, volcanoes form anywhere that magma can ascend through the crust. This happens anywhere that the pressure is low enough and the temperature high enough to let the rock liquefy and expand. The areas surrounding subduction zones provide just such conditions, so most submerged volcanoes accordingly appear around subduction zones. There are other places in the crust, though, that allow magma to rise and volcanoes to form. These other places are called hotspots. Hotspot volcanoes in general are known for having less viscous magma, and resultantly are more known for non-explosive eruptions than explosive eruptions. Hotspots tend to remain stationary, even as tectonic plates move above them. As a result, mountains and islands that grew above them after years of non-explosive eruptions eventually move away from the hotspot. When this happens, a new mountain and island begin to grow over the hotspot. Island archipelagos, like the Hawaiian Islands and the Galapagos Islands, formed in this way, with an island growing over a hotspot, the tectonic plate moving, and a new island forming. The old islands continue to weather and erode after they move away from the hotspot and stop growing. So these island chains usually have a large island on one end that's still over the hotspot and growing, and smaller islands at the other end that stopped growing millions of years ago. No one knows the exact sequence of events leading up to and causing an eruption, so they can't be predicted with any certainty. However, there are warning signs that a volcano is going to erupt, and because of the severity of an eruption, they must be taken seriously. Warning signs that a volcano is going to erupt include earthquakes originating within the volcano, a change in the composition of gases venting from the volcano, and swelling in the mountain. Earthquakes occur because as magma rises and the rock of the mountain crack, pulses of energy are emanated, indicating that activity within the volcano has changed. A change to the gases venting from a volcano similarly signal a change from the volcano. As gases and magma rise within the volcano, they cause pressure to build and can actually make the mountain itself deform. Such deformity is clear evidence, again, that activity within the volcano is changing. The timeline of such changes is unknown. In some cases, volcanoes wait months after they start showing warning signs to erupt, but others erupt within hours. Due to this variability, any signs of eruption are taken seriously, and evacuations from the area surrounding a changing volcano begin quickly.